Okay, today we're going to talk about the remainder theorem and long division. This is long division with polynomials. As you remember from elementary school, you've done long division with numerals before. So that's going to be an expansion of things that you've already learned, but it's going to look a lot different when we have to deal with it with polynomials. So let's first talk about the remainder theorem. The remainder theorem is talking about, actually, you know what? Before we do that, let's just do some long division. Let's say that we want to do 485 divided by 3. Okay, so we're just going to go ahead and divide 3 into 485. This is to remind us how we do long division. So first question is, how many times does 3 go into 4 without going over? Well, that's once. 3, then we multiply. 3 times 1 is 3. We put that number down here. And then we end up subtracting. 4 minus 3 is 1. And then we bring down the next number as an 8. We're going to do it again. How many times does 3 go into 18 without going over? Well, that would be 6. 6 times 3 is 18. And then we subtract, and we get 0, and we bring down the 5. And how many times does 3 go into 5 without going over? Well, that would be once. And we subtract, and we get 2. And sometimes we call this as a remainder of 2. So it's 161th remainder of 2. Or the other way to write it is 161 and 2/3. So the remainder goes on top, and whatever you start with ends up on the bottom. So these are equivalent, and this is a review of elementary school long division. Now, we're going to talk about this remainder right here. In long division, we want to know if there's a remainder, because a lot of cases we want there to be no remainder. And we're going to try to save ourselves some time by checking to see if there's a remainder before we go ahead and do the long division. So the remainder theorem says this. I first need to figure out what number I'm going to plug in for x, and then I'm going to just plug it in and see what the remainder is. So we're going to start with our divisor, which in this case is x plus 1. We want to set it equal to 0 and find out what that would be. So if you can't already see it, it's going to be negative 1. If you're not sure, you subtract 1 from both sides, and you get x is equal to negative 1. So this is what we're going to plug in right here. So we're going to plug in negative 1 for here, here, and here. And with negatives, make sure you put parentheses around it. So whenever you write it, we're going to have negative 1 to the third plus negative 1 squared plus 2 times negative 1 minus 3. Now, negative 1 to the third is going to be negative 1, because negative to the third power is always going to be negative. Negative 1 squared, though, is going to be positive 1, because 1 squared is 1. And 2 times negative 1 will be negative 2 minus 3. And this gives us negative 5. So our remainder here is negative 5. So we know that we have a remainder of negative 5. Now let me show you long division, and we're going to do the same steps that we did before. But we already know what the remainder is. The remainder should be negative 5. Okay, so we're going to start by putting our divisor out front, and then the rest of it goes inside. And now we start dividing, just like we did before. We started with how many times does 3 go into 4 without going over? Well, we're going to say, don't worry about the plus 1. We're just the first number here. Oh, one thing I should say, if you're going to do this, these have to be in order, and you can't have any missing terms as they descend. So this is 3, 2, 1, and this is really x to the 0. So they're descending in order. If there's a missing term, you have to put in a 0. Okay, and it's a very important placeholder. It has to be in there, and I'll show you a case on that in a minute. And they have to be in descending order. This one is, so we won't worry about it. So let's start dividing. How many times does x, don't worry about the plus 1, how many times does x go into x to the third without going over? Well, it's a multiply problem, so it's going to end up being x squared. X times x squared is x to the third, so then we go multiply. X times x squared is x to the third. And then we multiply the rest of it. X squared times 1 is x squared. So all we do is we simply multiply. And then just like before, we subtract. So we start subtracting. And this is where we got to be really careful, because we're subtracting two things instead of just one thing like we did before. So we do x squared minus x squared is 0. X to the third minus x to the third is 0. X squared minus x squared is also 0. So we've got 0, and we bring down the next number, and we get 2x. Okay, you can ignore those zeros, so we got 2x. The question now is, how many times does x go into 2x without going over? As a matter of fact, because I have this plus 1, I'm going to bring down the minus 3 as well. So I got, how many times does x go into 2x without going over? Well, it goes in x times. No, it goes in 2 times. I don't know what I was thinking. So this is going to go in 2 times. So 2 times x is 2x. And 2 times 1 is 2. And here's where we got to be careful. We're subtracting. So we got 2x minus 2x is 0. Negative 3 minus 2 is negative 5. And if you don't see it right here, because it's easy to go negative 3 plus 2. That's not what this is. It's negative 3 minus a positive 2. And minus a positive is just negative. So it's negative 3 minus 2, which is negative 5. And we said the remainder was negative 5 to start with. So we're right. Up here at the top is what our answer was. So we got x plus 1. And when you divide this by x plus 1, you get the answer of x squared plus 2. And then you can actually go ahead and leave this as 2 sets of parentheses, and this is now considered factored form. So let's look at another case. Let's open up a new one. And let's say this time I want to divide, I don't know, x to the third plus 2x squared plus 5 by x minus 1. Okay. So first thing we're going to do, let's go ahead and check the remainder. So if we said x minus 1 is equal to 0, that means that x is going to be 1 because we had 1 to both sides. So let's plug in 1. So I got 1 to the third plus 2 times 1 squared plus 5. 1 squared is 1. Or 1 to the third is 1. 2 times 1 is, or 1 squared is 1. Times 2 is 2. Always do the squares first. And then lastly, we got plus 5. So we got 1 plus 2 plus 5, so it's 5, 6, 7, 8. And we're going to have a remainder of 8 when we do our long division. So let's make sure we have a remainder of 8. So we're going to set this up. We got x minus 1, and then we got x to the third plus 2x squared. Now notice there's an x missing. I need one, so I'm going to add a 0x before the plus 5. I can't have any missing terms when I do my long division. So anytime there's one missing, just add a 0 and that letter that's missing. So if there was 2x, if there was no x squared term, we'd add 0x squared. Since there's no x term, we'll add 0x. And now we start dividing. So how many times does x go in x to the third? Well, it goes in x squared times. Multiply it back out. X times x squared is x to the third. And then x squared times 1 is negative x squared. And then we're going to subtract from the original. So we get x to the third minus x to the third is 0. I don't need to write it because it's 0. But I got 2x squared minus another negative. So it's 2x squared minus negative x squared. Minus a negative becomes a plus. So this is really 2x squared plus x squared. So this is 3x squared. This is where you got to be really careful on this double negative. 2x squared minus negative x squared is 3x squared. Bring down the next term. Let's do it again. How many times does x go into 3x squared? Well, it goes in 3x times. X times 3x is 3x squared. And then 3x times negative 1 is negative 3x. And let's go ahead and do some more subtraction. And we got 3x squared minus 3x squared is 0. That's good. And we got 0 minus negative 3. Again, double negatives are going to cancel, and this leaves us with positive 3x. Bring down the next term. And let's do it one more time. How many times does x go into 3x? Well, it goes in 3 times. So 3 times x is 3x. And 3 times negative 1 is negative 3. And one last time, we're going to subtract. 3x take away 3x is 0, which is good. 5 minus negative 3. Minus negative becomes a plus, so this is really 5 plus 3, which is 8. And we have a remainder of 8, which is what we said we were going to have from a remainder theorem. So we did this right. And our solution, when you divide x to the third plus 2x squared plus 5 by x minus 1, is going to be x squared plus 3x plus 3. So that's our solution. If you want it in factored form, then you also have the original. So these two things multiplied out are going to give you our original, which was 2x squared plus 5. Okay, so factored form, and this is the solution. Oh, I forgot the remainder. Not very good. So if you want to put this in here, you have to put the remainder in there. So it's going to be plus 8 over x minus 1. And then x minus 1. Don't forget the remainder. I think I forgot the remainder on the other one too. I did. Shame on me. So this also had a remainder. It was a remainder of -5. So this should have minus 5 over x plus 1. All right, so see, real life, I make mistakes just like you do. We have to go correct it. So this is going to have a remainder of 5 over x plus 1. And this had a remainder of 8, so we have 8 over our divisor, which was x minus 2. Okay, so if you have any questions, please make sure you ask. The biggest problem with long division is just making lots of simple mistakes, especially when it comes to that minus. The only way to get better at it is to practice, so please go do some of the practice problems and practice, 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 and you will get better at it. But you're going to make mistakes just like I make mistakes. If you got questions, please ask.